Welcome. This video is from IBDP AISL Paper 1 TZ1 Time Zone 1 of May June 2022. Question number 13. A ball is dropped from a height of 1.8 meters. Then the maximum height reached by the ball after each bounce is 85% of the previous one. So R is going to be nothing but what? 85%, which is going to be 0.85. Next, show that the maximum height reached by the ball after the sixth bounce. So it's going to be 1.8 times 0.85 every times whole to the power of 6, which is going to be 0.68 meters, which is 68 centimeters. Find the number of times after the first bounce the maximum height reached is greater than 10 centimeters. So 1.8 and how many times we don't know. 0.85 whole to the power of n is greater than 0.1. Use the GDC over here and get the value of n as 17.8, but exact value you should be using 17. Find the total vertical distance traveled by the ball from which it is dropped for the fourth bounce. So what am I going to do it is, this is the first bounce, second bounce, third bounce, fourth bounce. Every time so you can see that it is traveling 2 times of the height. So I'm going to take the initial value as 1.8 and the common ratio as 0.85 and n is going to be 4. Then I'm going to use Sn formula, which is u1 times 1 minus r to the power of n upon 1 minus r. So which is u1 is 1.8, 1 minus 0.85 to the power of 4 by 1 minus 0.85. Simplify by that calculator. You should be able to get this answer as 5.735925, but it is going up and down 2 times, therefore total vertical distance is going to be 2 times of 5.735925, but for the first time it's not going 1.8 upwards, so minus 1.8. We can clearly see that this 1.8 is not there included because we are dropping from here. So we have to subtract it out, minus 1.8. So this will become 9.67185. In 3 significant figures, it's going to be 9.67 meters. So this question is based upon geometric sequence. So whatever the height it is rising above, the percentage of that height, that's going to be my common ratio. So 85% is the common ratio, which is going to be 0.85. Then use the geometric sequence formulas, then you should be able to get that answer. And don't forget to subtract 1.8 because for the first time it is not dropping down 1.8. We have been dropping it and it doesn't rises by 1.8, so subtract it out and we should be getting that answer as 9.67 in 3 significant figures.